Welcome back. In this video, we are going to solve problem 4-102 that is taken from chapter number 4, Axial Load, and book name is Mechanics of Material by RC Hibbeler. So statement is the rigid lever arm is supported by two A36 steel wires having the same diameter of 4 millimeter. Determine the smallest force P that will cause only one wire to yield, and in B part, both wires to yield. Consider A36 steel as an elastic, perfectly plastic material. So you can see this is a handle where P load is applied and there is wire AB and CD. At point E there is a pin support. So you have to find this force P which will cause one of the wire to yield, and in P part both wires to yield first. The material is A36, so I've written the given data. The rigid lever is supported by A36 steel wires, and the yield stress of these wires is 250 megapascal. That is taken from mechanical property of the table, and E is also taken 200 gigapascal. Diameter of both wires are same, which is 4 millimeter or 0.004. So you have to find the P for one wire to yield and both wire to yield. So let's start with the solution. Now you can see due to this load, there will be elongation in wire AB and CD. As a result, if you remove this wire, so the wire exert downward force on this handle. So we'll find this. So if you remove this wire AB, so there will be a reaction force of this wire which is FAB on the handle. Similarly, if you remove this wire CD, so there will be a vertical reaction force FCD which will be acting downward. And if you remove this pin support, so there will be horizontal reaction force which is EX, as well as vertical reaction force which will be equal to EY. So we will find this FAB and FCD by using equation of equilibrium. So the equation is sum of all moments about point E is equal to 0, and taking the counterclockwise movement as positive. So about point E, the first movement will be due to this force, and perpendicular distance is 300. Clear? And this is producing counterclockwise, so it will be positive. So I will write FAB into 300. The second movement is due to this FCD, and perpendicular distance is 150, and this is also producing counterclockwise, so it will be positive. So I will write plus FCD into 150. Clear? And the last force which is producing movement is this force, and perpendicular distance is 450, and it is producing clockwise movement, so it will be negative. So I will write minus P times 450 is equal to 0. These two forces are passing through this point E, so they are not producing any movement. That's why I haven't taken this. So if you divide this equation by 150 on both sides to simplify it, so we will get 2 times FAB plus FCD is equal to 3P. Let this is your equation number 1. Now you can see due to this load, there will be elongation in wire AB and CD. So as a result, point A will let point A move toward this. Clear? And point E is fixed, so it will be like this. So point C, this is new point of A dash, and this is C dash. So this distance between A and A dash is change in length of AB, and distance between C to C dash is change in length of CD. And you can see we get a triangle. Clear? Now here we have two right angle triangle. One is this one, and the second triangle is this one. These are similar triangle. So we will apply elastic analysis. I will write it elastic analysis in order to find the relationship between these two change in length. So by using similar triangle, if I take the side del AB divide by, initially I will take this larger triangle. So AB divided by this length, which is 300, will be equal to, now if I will take smallest triangle. So this CD, del CD divided by this length, which is 150. So del CD divided by 150. So from here I will get change in length of AB is equal to 300 divided by 150 into change of length of CD. So again it will give us change in length of AB is equal to 2 times change in length of CD. This is your another equation. Now if I further simplify it, change in length of AB is equal to 2 times change in length of CD. So change in length of AB will be equal to FAB into length of AB divided by area of AB into E is equal to 2 multiplied by FCD into LCD divided by ACD into E. Clear? Since both diameters are same, so area of AB is equal to area of CD will be equal to A, and length are also same. LAB is equal to length of CD is equal to L, which is equal to 300. So this will cancel with this, E and E will cancel because material is same and this are same. So we will get FAB is equal to 2 times FCD. And this is your equation number 2. Now what we will do is that our first part is that assume one wire to yield and yield. So we will assume that wire AB will yield. Why? Because in previous problem we have seen that wire AB yields. So this force in AB will be equal to yield stress multiplied by area of AB. Yield stress is 250 megapascal, so 250 into 10 raised to power 3 multiplied by area pi by 4, diameter is 0.004 square. So from here when you calculate it, you will get force in AB will be equal to 3141.59 Newton. So this is the value of force in wire AB. So put this FAB in equation number 2, which is this one. So FCD will be equal to FAB divided by 2. So 3141.59 divided by 2 will give you 1570.80 Newton. So I will get FCD is equal to 1570.80 Newton. Now you have the value of FAB and FCD. So what we will do is that put FAB and FCD in equation number 1, which is this one. Clear? So when you put it 2 times FAB, which is 3141.59 plus FCD is 1570.80 is equal to 3P, and when you solve this you will get P will be equal to 2618 Newton, or you can say P will be in term of kilonewton, it will be 2.62 kilonewton, which is the answer of our first part. Now we will move toward second part, that both wire yield. So again I will move toward the next page. So for as this will fail, so we'll move that plastic analysis there, and we will write since both wires AB and CD are required to yield, Therefore, force in AB is equal to force in CD, and that will be equal to yield stress of steel multiplied by the area. So 250 is the value of yield stress multiplied by the area is pi by 4 d square, and d 0.004 square. So when you solve this, you will get the value of forces in both wire will be 3141.59 Newton. This will be equal to FAB and equal to FCD. Now put FAB and FCD in equation number 1, which is again this equation. This is the equation 2 times FAB plus FCD is equal to 3 times P. So P will be equal to 2 by 3, 2. P will be equal to 2 by 3 times FAB plus 1 by 3 times FCD. So put the value 2 by 3, 3141.59 plus 1 by 3 times 3141.59. And when you solve this, you will get this P will be equal to 3141.59 Newton, or in kilonewton it will be 3.14 kilonewton, which is the answer of our second part. For both wire to be yield, P should be equal to 3.14, while in first part P should be equal to 2.62 kilonewton for one wire to yield. And that was all about this problem 4-102. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then hit the bell icon and subscribe my channel as well. So that was all about today's. I hope you have enjoyed. Kindly share my channel with your friends and help me in growing my channel further. Thank you for watching.